So you probably saw my shirt and my shoes. And because I thought I'm in the Netherlands, and I love the Netherlands, and to show you my appreciation, I created this T-shirt to get a proper dress for this conference. So, yay! Oranje, right? This is the, yeah, that's so great. Welcome to the session. We hate code. I hope I can focus on all of you. It's a new experience, but it's great. The not joy of maintaining dead code. So my name is Gerrit Grunwald. I'm working for Azul. Yes, I know it's not blue, but you know the reason. We do JVMs, everything around Java, but that should be it. If you would like to contact me, just ping me on LinkedIn, right? So I will accept. Who's a software developer in the room? Java developer. Okay. Who loves to maintain bad code? Honestly. Okay. Yeah, I know you do, Tom. So who has to maintain code? Okay, nice. Okay, cool. So because we have different kinds of bad code, the whole thing of dead code, bad code, there's not a proper definition. So I will define something for this session, and then I will let you know. So we start with legacy code, right? We all know that. And there's so-called dead code, right? And this is sometimes the same, sometimes not, depends. If we start with legacy code, then yeah, this is code that was written for no longer supported hardware or operating systems or whatever, so it can't be tested automatically, is no longer developed or maintained by anyone, or lacks documentation. In short, it's code you're afraid to touch, usually, right? It still works, which is fine. Don't touch, never change a running system, right? So this kind of thing, you know that. So who has to handle legacy code in the company? Nice. So it's usually in banks and insurance companies. That's what from my experience, when I worked as a consultant, it's really like you find the whole session is maybe beneficial for people who work in banks and insurance companies because they have this old code bases and they know what I'm talking about. So how to deal with it? Yeah, we know that there's refactoring, there's rewrite everything. You can find out if it is used at all and remove it. Refactoring, sure, we know that you have to understand the code first before you start refactoring, which is sometimes not that easy. You can use static code analysis tools like checkstyle, spotbugs, PMD, SonarCube, and others. The problem is time, right? So you probably know that you see the code, you go to your manager, you say, oh, I saw that code, we maybe should refactor it. Then you have some suggestions, and your manager says, yeah, this is really good stuff, so open the ticket. You open the ticket, and then that's it, right? And then years later, you find, oh, yeah, look, this ticket. We did it already 10 years ago, but nobody really worked on that. So rewrite could be even worse. So who did a rewrite here in the audience? Oh, just a few, right? So it's, again, you need to know the requirements. In this case, you also need to know exactly what the code does. And you need to know the requirements is also not that easy, especially if you have to rewrite stuff that is maybe 5 or 10 years old. Probably the people who wrote it are not in the company anymore. So finding the requirements from that day, sometimes hard. Now my clicker stopped working again, okay. It's in principle like a new project with everything involved, right? So all the cost, all the work, all the time. And the problem is time and money here. So if you come to your manager and say, we have to rewrite the whole stuff, then usually it's, no. We just keep it like it is, and then we will work on the new stuff, and then we will replace it in the future. But not really rewrite. So this is rare. So I'm surprised that so many people did a rewrite here. Which leads me to dead code, right? So because legacy code, sometimes you can't really avoid it. It's just there. Dead code is different. Dead code usually is stuff like unused imports of variables, methods, and classes, like unreachable code. Right? You have methods that won't be called at all. Redundant code, yeah, we know all that. And obsolete code, right? The code that is, yeah, you don't really need it, but you are really afraid to remove it. So, and also stuff that is commented out. So who comments out code here in the audience? You can be honest. I do that all the time. And I will be honest with you, I wrote a couple of libraries, and I always sometimes I see this method and yeah, I don't really need it, but it looks so good. And maybe I need it next year. I just make a comment. Cool. So, and then I still have it, and it sticks in the code base forever. So the risk of keeping it, this dead code, is first of all, you increase the complexity. Definitely, because young ones that come to your project, they read through all this stuff and they think, this is serious code. I need to understand it, right? And then, you don't, it's just old stuff. Just ignore it. But how to figure out which stuff to ignore and which not? Reduce performance, definitely. It can introduce risks for bugs, which leads to security vulnerabilities, and also code review delays, right? Because you have to review all this stuff in there. Even if the developers sometimes know, this is not used, but the people who do the review probably won't know, right? So they review all this stuff, and that really, it's terrible. So I had that experience in some of the projects I was working on. So where does it come from? Probably you know these reasons. So rapid development, build now, fix later, right? Who knows that? We have deadlines, and then, come on, we need it. Can you just build it? Yeah, but there's a problem. Yeah, we fix it next month. Yeah, you will never fix it, right? It will stick in there, and it's terrible. And this is my problem, hesitance to delete. It's really like you write this code, and it's so beautiful, and it works, and it's great, and you can't delete it. It's really like, okay, you mark it, okay, I comment out. This is great. It's the first step, and I will never do the second one. So merging code branches, also very popular. You merge some stuff, and suddenly you have the same functionality in different methods, and then because the tests will pass, say, it's good, it's all green, just leave it, because you don't really review what's in there. And the lack of awareness. So I worked once in a project in Singapore for 1.5 years, and that was terrible, because we came as a Swiss company into the Singapore bank, and we had to integrate our code into their code base. And that was 1.5 years, and then I left. And these people had no idea what we did. So there was not really an exchange, and so that means if something goes wrong, they have no idea what's the problem. But you find that stuff. So it's in big projects, it's really hard to keep an overview about all these things that can go wrong. So and you pile up code. But removing that code, fortunately, is not that hard, right? So we have IDEs. Who's working with IntelliJ here? Now the more Microsoft, someone? Visual Studio Code? Yeah, and now the good ones, NetBeans. Gerrit, I knew it. Oh, there's Eclipse. Someone using Eclipse? Oh, one, okay. I thought it's dead. It seems to be still alive. So if you, for example, in IntelliJ, pretty easy, you know all that. You have a method that's not used. There are tools to do that, and you see it will tell you this method or this variable is not used, you can remove it. Easy. So this is good. There's SonarQube IDE. I think it was called SonarQube Linker before. Same thing, more configurable, so you can just define the stuff it should find, and then it will find it, mark it, you can remove it. Good. So this is at least possible, right? So that's easy. There's Open Rewrite. Who knows Open Rewrite? Awesome. Who uses it really in production? Okay, still cool. It's a community-driven project and enables developers to effectively eliminate technical debt. They use some kind of recipes and have this auto-refactoring engine. And what you can do is you can either write your own recipe, or you can choose one, because they have lots of them in some kind of a catalog. So, and what it is, that this is the same code. So we have one method which isn't called, and then I have my Maven file, and then you see I have a plugin, and it's you see what it does. It does remove unused private methods. This is the recipe that I added here. And if I execute it, mvn rewrite run, then this is the code how it looks before, and afterwards just removed. Advantage here is I can run that on the whole code base, right? So, and then it will remove all the stuff, and you can create then a pull request, and then it's cleaned up. So this is the ideal world, right? So, which is good, because it will find the stuff that is not used. Nice. The problem is if we have zombie code. Who knows what zombie code is? Yeah, this is the interesting part. This is code that is maintained, and you have tests for it. That means someone is calling this code. So the IDE won't find it. Also, Open Rewrite won't find it. So that you can think about something, you have a web shop, and 5 years back, someone had the idea, we need this feature. There was a feature request. It passed through, you implement it, but how do you know that this is really used by customers? Who's monitoring that? Someone monitoring that here in the audience? If your stuff is really used? If someone really pressed the button that was implemented because some product manager has this super nice idea to edit? Yeah, that's tough, right? So you don't do that usually. So the code is never executed in production, but you maintain it. That means you put it from one version to the next one to the next one. You write the tests, you make sure everything's green, but you never really prove if it's used. When I heard that the first time, I thought, yeah, it couldn't be that much, right? It's maybe 5%, maybe. Well, some things how it can happen, right? You have a challenge, let's say. Someone comes to you and says, oh, I have to add this matrix multiplication, right? I have no idea how to do it. So you ask the other dev. He said, oh, yeah, Apache Commons. There is a method you can use there. Oh, this is so cool. So I do, and add it as dependency, because it's so easy, right? Instead of just figuring out how to do it, I just add the dependency. That means I add, in this case, it's 124 kilobyte. Doesn't sound like a lot, right? 16 classes, 224 methods to use one method. And we know that. We all have been there, right? It's like, oh, I don't know how to do it. Oh, there's this library, cool. Add it as dependency, use the method, done. Well, that means this is the code you need. It's 2 methods. It's not really hard to do that. But we are all so lazy and under pressure, right? We have to fulfill the deadlines. So that leads to the fact that we add, instead of 2 methods, all these methods, but we only use one of that. Now you might argue, yeah, but we can't change it, right? So because I need the method. But if it's something like Apache Commons, you could even copy it out of the code base of the library into your code, and you get rid of the rest, right? Because you don't really need the library just for this one method. So other difficulties with this kind of approaches, do we have library developers here, or framework developers? Yeah, the hard part with this stuff is you really have to think twice before you make any method public, because you probably can't remove it anymore in the future because you have no idea if it's used. And I can't help you with this, because as a library developer, I do myself, I have no idea what people are using and what not. I add stuff that I think is useful or that people request, but if they really use it, I don't know, right? So once it's public, there's no way back, usually. And if you use AI, it could be even worse, right? Because then you might not even be aware of the amount of code that was added to your code base, because you just let the AI produce it and you just use it without really knowing what's going on. And especially with the young ones, I saw that in the past year quite a lot. So they just use it because it works without really understanding the drawback that you might have in 5 years, right, with this stuff. So the problem is how to find this code. There are different ways of doing that. You can only do it in a running system. There's no way to really do it with a static analysis tool or something, because you need to know if it's used, and you can only do that in a runtime environment. So there's something called tombstone logging. Has someone ever heard about that? It's not really the well-known definition, but what it is, it sounds weird, but it works. You can use log4j, for example, and you use custom log levels and use static initializers. And then you add this to all of your classes and methods. Yeah, that sounds weird. And this is, for example, how you define a custom log level in log4j. I defined one for used class and used method. And then you have a static initializer. That means this static block will be called every time you create an instance of this method, of this class. So it will lock using the used class level, right? And then in each method, I have 4 methods, and 3 only will be called. I have this other log level, right? It's pretty simple to understand the approach, because you just log everything that was called. That means you get a huge log file, you get all the information about the used code, not the unused code, right? But at least this is one approach. And then this might be the output, right? You see, okay, the main class was called with the used class level, and then I have a call for method 1, 2, and 4. 3 never have been called in production. So the same thing you can do with flight recorder. Is someone using flight recorder here? Just a few. You should do. It's really cool. And it's cheaper than logging sometimes. So you, instead of creating custom log levels, you create custom flight recorder events, right? And then the approach is exactly the same. Instead of logging, you just fire these events, and then this would be the code. Pretty much the same as before. We have two different levels, like the used class event and the used method event. And you can define whatever you would like to have in there. So I just have the name of the method and class. And then we do exactly the same. Initializer, we call the one, we fire the one event, and then in the methods, we fire the method events, right? And then in this case, we have mission control, which is the tool that comes with flight recorder. And then you can see, for example, something like this, where it says we have the different methods that have been called. So this is like a log file analyzer, right? Mission control gives you the opportunity to read these logs that have been created by flight recorder. Okay, that's good. We can figure out what was called in production, which is not too bad. Finding the unused code, this is a little bit of a challenge, because here, now you have to find all the classes and all the methods in your code base, right? And there's something called the ASM tools. I don't know if someone heard about that stuff. This is also used in the JDK. Or you can use the class file API, which is in JDK 23 and onwards. And with this one, you can scan through your jar files, and it will tell you exactly all the classes with all the methods in there, including initializers and all these kind of stuff. So then after that, you have to create a diff of all your log file output and all the classes that you found in methods, and then you get the diff, and this is the unused code, right? It is possible, but yeah, it's a lot of work, as you can see, right? Because you have to create a log file that you can afterwards get all the methods and classes out of it. Then you have to use ASM tools or class file API to get all the available classes and methods, and then you have to create the diff out of it, right? And then you have the unused code. So yeah, like I said, it's possible, but a lot of work. There are also other solutions, and one is done by a company, or it was at least presented by a company that I know from the Netherlands. There's Java code coverage, Jacoco. Who knows that? That's good, because you can use this to detect unused code. And there's a combination of Open Rewrite and Intelligence Cloud, and I will explain both of them. There's a third one, but I'm afraid we don't have the time to talk about the third one. First of all, who knows what a Java agent is? Okay, so let me shortly explain, because this is important. I told you we have to analyze a running JVM, right? And if you would like to do that, then you have to somehow find a way to ask the JVM what's going on at runtime while your code is running. So and if we take the JVM as a black box, which is not true, right? So it has different parts. As you can see, it has a class loader subsystem, JVM memory, and also the execution engine, and it comes with an API. So every OpenJDK and also the OpenJ9 one from IBM has a so-called instrumentation API, and that means at runtime you can talk to the JVM, right? So that means, and therefore you need an agent, that so-called agent, which is also a Java program. So the Java agent can then hook up callbacks to these systems in the JVM. For example, in this case, the agent is interested in the class loading subsystem, so it can hook up a callback to the class loading subsystem. Every time the JVM is loading a class, it will tell the agent, I loaded this class, stuff like this, right? And the same can go on for methods, right? And so with this approach, you can log all the information that's going on at runtime. At least you can get the used stuff. So Jacoco is not really made for that. So Jacoco was made, it's a free tool to report code coverage on automated test suites. And it collects coverage metrics using a Java agent, right? So, and you can tweak it in a way that you can get the information that we are interested in. And usually you do that in development, not really in production. The problem with this agent is that it was not made for that. So it was made for collecting other data, so it collects more stuff than we really need. So, and that means we have to really don't use all the functionality, and be careful what we monitor because it can bring down performance. This is usually true with agents in any case. So because the agent is talking to the JVM, while the JVM is running your program, you can imagine if the agent really asks a lot of stuff, then the JVM needs some performance to talk to the agent and provide the information that can bring down performance. So you have to be careful with this. So finding zombie code, in this case, would be you have a jar file, then you run it in your application, you attach the agent to the JVM, and now you have to really tell the agent which packages it should look at, because this agent collects more data than we need, right? So, and usually, because if you use Spring Boot, I guess 80% is who's using Spring Boot? Yeah, see, and you can't really remove stuff from Spring Boot, right? So why logging that stuff? So it's more interesting to log libraries that you add, and also the code that is written by yourself or by your company. So you usually put the agent just on the packages that you can change afterwards. So then the stuff runs and reports into Jacoco, and then you run that for some time. And when I say some time, I'm talking about months. So 6 months, maybe 12. And the reason for that is obvious. If you work in a bank or insurance company, you have jobs that only run once a year, right? So how to make sure that you really cover this stuff? You don't want to remove code that might be needed just every 2 years or something. So you need some domain knowledge before you do that. You can't just run it and after a day get the result. It doesn't work like this. This is a really long-running process, and you have to be careful with this. But you can do, and afterwards you can use the Jacoco CLI to gather the data from Jacoco. Then it will create a so-called data file. Then again, using the CLI to create from this data file a report. Right? So if you're interested in this approach, then still you have to manually, because you only get the used code. Right? This is the problem. But there is, from the company Picnic, you probably know that, they have a blog post that you can find here, where they explain how they use it in a microservice environment. Who's working with microservices here? Who's working on a monolith? Okay? There is another blog post, and in this one, this is based on another one, where the guy who created the other one is showing the same example for a monolith. So you can also use it for this one. It's quite interesting because they show you what they did. And in the end, it's the same approach. You somehow have to collect all the data and then do the diff, right? This is the problem with this approach. So Jacoco is free. You can find it on GitHub. A drawbacks I already mentioned. Code has to be removed manually. Right, so you get a list, and then you have to go through the list and remove the stuff, which can take some time. To give you one example, we have one customer. It's a big one. I'm not allowed to tell you the name here. But this customer, we ran the stuff and for 6 months, and we found out that 70% of the code was not called in production in half a year. And we couldn't believe it because it was so much. I was like, oh, we can't tell them. It's too hard. So, okay, we double-checked and ran again, and it was 70%. So we told them, and then they bought, right? So, oh, okay, this is really cool. Because, yeah, it's amazing. And we have other customers, same experience. So they have jar files as dependencies, 200 jar files as dependencies that are not used at all. Not one method is called in that jar files, and they deploy it every time, and they maintain this stuff. And when we showed them, they say, "Oh, wow, that's a lot." Yeah, you can remove it, right? So, but still, you have to remove it manually, which might be a hassle. So, we partner with Open Rewrite. So, Intelligence Cloud is something that we run. So, because Open Rewrite can remove code automatically, right? And we can find that code. And how we do it, I will explain shortly. It's pretty much the same approach. So we have a cloud service, and instead of collecting it locally, we collect the data from the JVMs using an agent, and we put it into the cloud. And we can do that for all OpenJDK versions, also for OpenJ9. And we also use an agent. But our agent is different because we just created it for this. So it only gets this tiny information. So we have a runtime overhead, but it's below 1%. So this is not really a problem related to performance. And we can give you used and unused code. So this is also the other difference. So with us, you get a report that says this code was used, this code was not used. So we do the whole diff thing automatically. So with this one, it looks like that instead of running it just on one machine, we can even run it on multiple machines at the same time. Could be different architectures because it doesn't really matter. Because it's all Java, we have the agents connecting to the JVM. And now the difference here is all these agents will talk to one point, which we call the forwarder. And we can tag an application. Because the problem is, if you have, who does, for example, continuous deployment here? How often? Let's give me numbers. Once a day? Multiple times per day. So, and if you have version numbers, and you probably have, right? So then the problem is, okay, if you add and remove stuff on a daily basis, how to find the things afterwards, right? Because it's really tough. If you have to run it for 6 months, that means there's a lot of versions piling up. So we tag, you can tag the versions that you run. And this text later on in the cloud can be filtered. So if you are smart with tagging, you can just tag, for example, in this case, my app v, and then all the versions for this app will be in one log file, for example. So this data then goes to the cloud and will be stored there and analyzed there. And then you have to run it, right? And this is really, that's the boring thing. You can always ping it. You can start it and you can ping it after an hour if you like. So, or after 2, after a day, whenever you like, you can create reports. But the reports will get better and better over time. That's the point. So then you can use either the web interface and download the report, right? It looks like this. You don't have to really look at it. It's too small anyway. But you just get all the lists of all the components that have been used or unused. Or you can also create a client tool, right? So I wrote my own one because I would like to test the API that we have, and then create the same. So this is my tool where I just get something that looks like in an IDE. So I get the same structure that I see in IntelliJ, and everything that's used is gray, and everything that's not used is white. So and this goes down to the method level. And then I can also see numbers like how many percent or how much percentage of a package or jar file or class was used, right? That can help if you have dependencies where you only use 1 or 2 methods or 1 class. So you might be able to get rid of the whole dependency if you figure out what is the class that was used or what is the method that was used, and then just use it and just put the code in your own code base and get rid of the whole dependency, right? Especially with microservices, that will reduce the deployment size of your artifact. So that is sometimes, that's really a problem, especially if you have to scale up fast, then these things matter, right? So it doesn't really matter if you have a, let's say, an application server that you start once a month, right? So then you don't really care about these kind of things. Okay, so yeah, you get information about, like I said, class information, methods used, and all these kind of things. The interesting part is because now we only have the report. Okay, I know this is used, this is not used, but still somehow I have to remove the code, right, manually. And now Open Rewrite comes into play. They created a recipe where they can directly access the intelligence cloud stuff using the recipe. And then they run for the first time after 6 months. And what they can do, they analyze it the same way we do it. And now this is the beauty of it. They can add deprecation annotations to your code base, right? So they just add that. And there's a deprecated annotation, so they can add it, and it's, in this case, for example, add deprecated, since you can put some text, and then there is for removal equals false. This is the default what they do. So that means after 6 months, suddenly in your code base, this stuff appears. You see, oh, this wasn't called the last 6 months. So, but nothing else happens. It's just in your code base. And then after, let's say, 3 to 6 months, you can run it again, and it will either remove stuff that was deprecated before if it was called in between, or it will change the flag from for removal false to for removal true. This could be possible, right? And then that means you could identify the stuff that was, again, not called. And you can remove this step a couple of times, right? It depends, because this is really very individual depending on your code base. But then in the final step, you can decide, okay, now I would like to remove all the stuff that was annotated with deprecated, and then removal false, removal true. And so then the whole stuff can automatically remove from your code base. Of course, you have to do a pull request and then really review this request, because you don't want to remove stuff that is probably used in 2 years, right? So you need really domain knowledge to do that. So you can't just remove. But at least it can remove the whole stuff completely, automatically, so you don't have to do it manually. How we are on time? Oh, we are good. So this doesn't come without challenges, of course, because like I already mentioned, continuous deployment might be a problem. So if we have this example where we have different versions, then you have to be aware of how to tag these versions correctly. Like in this case, I just give you an example, right? And then later on, if you filter, you can define filters when you create the reports. You can filter for something like app v1 dot. And that means everything that has 1.1, 1.0, and so on, you will get all this in one big report, and you will also see the text. So that means even afterwards you can identify this was version then from that day, because you also get the information when it was the first time called, the last time called, and stuff like that. So but this is still a challenge, especially if you have multiple deployments a day. Then this is a tricky part. It's not so easy to monitor that. Yeah, but you can solve it using tags, right? As already mentioned, the final merge request, that's the critical one. Because if you don't really do a good review, you might remove stuff that might be needed in the future. You don't know, right? So, and you don't want to break the code. Yeah, code may be needed in the future, so that means you really need people that have domain knowledge, because sometimes it's not really the developers, it's the people from the domain. They know, yeah, but we have this process that runs, I don't know, every 6 years, right? Make sure that this code still is there, right? So stuff like that. If you need more information, you can look it up on the web. So it's Intelligence Cloud, one of our products. Another thing, and that's quite interesting, is the costs that are involved by maintaining this bad code. Because I wasn't really aware that, first of all, I never really thought about it, that there is really cost involved when maintaining bad code. And there I found some studies about that, and it's quite interesting. So dealing with bad code, right, for 4 hours a week, and who would say this is true? 4 hours a week maintaining code? Someone here? Less or more? More, okay? Makes it even worse. If you do it 4 hours a week, they figured out it's 85 billion annually, right, that it creates in cost. This is big numbers. This is a US study. They love these big numbers. If you would like to know more, you will find it here, which is nice, but yeah, doesn't really tell me a lot. There's another, this is a thesis, a PhD, where this guy figured out if you have 100,000 lines of code, if a company has 100,000 lines of code, then for this 100,000 lines, they pay around $361,000 on technical debt a year. That's what his study figured out, which is, again, it's big numbers, it's interesting, but doesn't really help me as a developer. So if we break that down, this is probably not available yet, because it will be public available next year. So now you can just go there and buy it, but you can't really get it for free because it's still too new. Yeah, like I said, this is big numbers. Maybe a little bit too abstract for us as a developer. So to break it down, you can say each line of bad code, and bad code includes legacy code, dead code, and also zombie code, boils down to $2 to $5 per line. If you have a company have around 100 million lines of code, means, and you have 30% of that code, which is not really, it's quite realistic, then we talk about 300,000 lines of code, means it's $600,000 a year, plus the time that you spend maintaining this stuff. And if you think about it, then it could, first of all, save your company a lot of money and time, and this time you can invest in other stuff that makes more sense. But usually, we are so used to maintain that code that it's just part of our job, right? Nobody really thinks about that you can save money by just removing the stuff. And I was surprised when I heard about these numbers that I told you, with 70% unused code. It's just because people don't think about it. They just add new stuff. Yeah, it works, just keep going. And at some point, it's just too much. So the conclusion, zombie code is real. And I showed you my tool that I wrote, right? It is really just this tool for this demo. And I ran it to check what code is really used. And even in this demo, 37% of the code was used. The rest was unused. I was surprised, because I thought, oh, well, this is just handwritten stuff. I don't use any big frameworks. This is really just Java code. But I used libraries that I wrote that contain a lot of stuff that I don't use. So it's it's interesting to run this stuff. Intelligence Cloud is not for free, so if you're interested in that, just to figuring it out, we are working on some kind of where you can test it for free to make some tests, or you can even use Jacoco to do that. And if you have small projects, even the logging approach is quite interesting to figure out these numbers. So monitoring takes time. That's the biggest drawback, and that might be a problem to convince managers, because if you tell them, you have to at least run it for 6 months, then people say, nah, I don't want to do that. I would like to have the result tomorrow. No, you won't get it. So this is the drawback, and you can explain why. Right? It's not that easy. Jacoco and Open Rewrite, or Intelligence Cloud and Open Rewrite, that could help to solve this problem, remove this code. So it's probably worth taking a look, at least at the Jacoco stuff, if you would like to play around with things, to get an idea, and read the blog post from Picnic, because they explain in detail what they did, and they use that on a daily basis to get rid of that code, because they figured out even them, which is quite a young company, have to deal with it. So now imagine you work in a bank or insurance company with code bases older than 15 years. That's a pile of code that might be worth removing, right? So but it's hard to do. That's why we created these tools. Yeah, and you need domain knowledge, definitely. So it's not something that a developer can do on his own. So this is something that it goes to different domains in your company, and you have to check with each of them. So it takes some time, but it's worth it. Yes, of course, it's a cost factor, right? So I wasn't aware before I read the numbers, and then I checked, and you will find these studies. So people do studies about that, because they figured out there is really a problem. And it's a lot of money that we spend on that without knowing it, because we just accept it like it is, but we don't have to. We can change it, right? With this, I think I'm good in time, so I thank you for attending. I hope it was somehow interesting. If you have questions, I will be here the whole day. Just come to me. I think you can find me. I am shining bright in the orange color. Apart from that, enjoy the rest of this awesome conference. Thanks.